Hello, welcome to the first online class taught by myself, Mr. Otto. Um, this is going to be a learning process for all of us, so please be patient. Hopefully, this setup I have right now will be okay. As you can see, it's a little interesting. I'm trying to be, I don't know, use a little innovation, a little ingenuity in order to create this kind of document camera situation so I can help write stuff out for you all as we go along. But yeah, so basically be patient. I'll say this every time, every class, but if you have any questions, please email me. And when you email me though, please include some sort of picture or well, yeah, no, include some sort of picture, but make it descriptive. So because if you send me an email saying I don't know how to do question 3, sure, that may be true, but what about question 3? What about the specific question do you not understand? Is it a part of maybe the math you may not totally understand? Is it something else? Make sure I know exactly what you're asking, and the best way to do that is by using a picture. Draw out where you're stuck. Show me a picture of what you've done so far. Yeah, y'all get it. Okay, I don't want to make this too long, so I'm just gonna get into it. Basically, today it's Tuesday. We are going to start by I'm just going to quickly go over what we talked about before spring break. Um, and it's been a long time, and I know that you probably have forgotten some of how to do it all, but I want to quickly go over it because I'm going to have you today just do a little bit of a review, and then tomorrow we're going to move on to the next section, next steps. Okay, cool. So first things first, as you remember, we talked about Ohm's law. So Ohm's law can be drawn with the triangle that we love so dearly. Start with the triangle, draw a line through the middle, draw a line down, you make a little T in the middle. So it's voltage V not equal, this is current I and resistance R. So again, V equals voltage, which is measured in volts, represented by V. Yeah, I could probably write a little bit bigger. I'll do that. Then we have current. So current is I, which is measured in amps. It's plural because there's multiple of them, which is represented by an A. There we go. Lastly, resistance. Pretty easy. Resistance equals R. It's measured in ohms, hence Ohm's law, which is represented by the Greek symbol for omega, the horseshoe shape. So if that's not a perfect shape, not a perfect horseshoe, I'm not going to be mad. You do your best. Okay, so the equations for all three of these different values is as follows, as you should remember. You just look at the triangle. So if you're looking for voltage, you take the voltage out. So we're going to take the voltage out, put that right here. Voltage equals, and then what's left? If you take that out, you just have current and resistance. And then they're right next to each other. So you do voltage equals current times resistance. Pretty easy. So same things with other ones. Let's say we want to do resistance next. Resistance equals, and that was a weird equal sign, but it's fine. Resistance hide the R, V over I. Voltage divided by current. Pretty simple stuff. You should remember all of this. There we go. The three equations that we will use to solve things. So I'm not going to do any practice problems with giving you two values and you solving them because you should know how to do that. If I give you current resistance, I expect that you will be able to calculate voltage from that. Pretty easy stuff. So what I'm going to do is I'm just going to jump into some more complicated practice problems. So as you probably remember, I'm going to move my document camera to the side a little bit. It's a weird system. We're going to make it work though. So I'm going to draw a quick circuit. Let's say we have our battery, which is represented by these lines, as you remember. So coming out here, we have, there we go, our 1 resistor, 2 resistor. There we go. So resistor 1 is equal to 10 ohms. Resistor 2 down here is going to be equal to 20 ohms. Let's do that. So finding, and then we have our voltage over here, which voltage is going to be equal to 9 volts. All right, cool. We have our first problem. So reminder to solve resistance total in a series circuit only. So this is considered a series circuit because these two resistors found, resistor 1, resistor 2, those are in series. They're in a line. There's no branches coming out over here to make another branch. There's nothing special to it. It's a simple line with multiple components being the two resistors on the same line. That's pretty much what it is. So resistance total in a series circuit is equal to resistance 1 plus resistance 2. And then if we had more resistors, you would add them on. So plus resistor 3, resistor 4, resistor 5, so on and so forth. Pretty easy stuff. So this one's pretty easy. So it'll be 10 ohms plus 20 ohms, which equals 30 ohms equals resistance total in this circuit. Like that. Super easy. You all know that. All right. So now if I said, okay, I want to find the total current of this circuit. So current total is equal to, as you can see over here with our equations, current equals voltage divided by resistance. So voltage total, which we have the voltage total right here, 9 volts, it's given to us, then divided by resistance total. So that equals 9 over, we just take this 30, put it right here, and 9 divided by 30, not totally sure what that is, but it's pretty easy. But yes. Okay. Super simple, super easy. The last thing I want to talk about is, let me move this up here. There we go. So we have another circuit, another series circuit is going to be super easy. We're going to do our power source and then 2 resistors again. When you draw them out, these are not perfect. They're not identical. That is totally fine. My battery over here, as you can see, it's a little more spread out. That's totally fine. All that matters is you get the general shape. So if I look at this, I know I'm trying to express a resistor. If I see this, I know it's a battery. It does not need to be perfect. So we have resistance 1 equals 10k ohms. Then we have resistance 2 equals 220 ohms. So I ran out of space. That's fine. So when solving this, and yeah, we're not going to worry about voltage. I just want to talk about the resistances. So resistance total in this case, when you are doing any equation with these problems, if you have a prefix, so a number that has a K, so kilo ohms, milliohms, microohms, whatever it is, you have to convert this to its base value. Base value means just this, what am I trying to say? Unit, just this unit. It can't have any prefix to it. It has to be just ohms or just amps or just voltage, whatever it is. So with K, we're doing kilo. So kilo ohms, that means so let's write that down here. So if we have our base, I'm just going to do amps because it's an easy letter. So if I have kilo ohms and I'm trying to move it to regular ohms, I need to move my decimal place to the right 3 spots. So that would make this right here 10,000 ohms. So then when I move this back 1, 2, 3, it would be 10k ohms right there. Cool. So I'm gonna make a little key. So if I'm going from amps and I want to move, if I move my decimal place 3 to the left, that would mean I now have a k in front of my unit. So that means, and then I would know. So if I have 5 kiloamps, I would have to know. Oh, because my key, that means I have to move my decimal place 3 to the left, 3 to the right. I'm sorry, because I now have to go back to the base right here. Yes, and then so on this side, I'll do the same with 1, 2, 3 with the lowercase m, so that way I know I'll have to move it 3 to the left when I'm converting it back. Super simple. That's just an easy way to help get a little, make sure you're converting things properly. So to finish this up really fast, we do the normal equation, plus 220. That means our total resistance is 10,220 ohms. And so in this case, I want to convert this, simplify that a little bit. So I'm going to make that 10.22 kilo ohms because I moved it 1, 2, 3, just like that. All right, cool. So now what we're going to do parallel circuits. So parallel circuits are a little more challenging, but not too much more challenging. You all should remember how I'm just going to go this page, flip this over. There we go. Gotta be careful not to knock over my document camera that I am so smart and I made myself. It's crazy. So with a parallel circuit, I'm going to draw one out really fast. We're going to do, starting here, we're going to do 9 volts going up. We're going to do one resistor right here, going back, another resistor right here. So they are parallel circuits because these two lines, in theory, they're not perfect. These are in parallel, meaning that they are two separate branches that run directly along with each other. So we're going to do this resistor. Resistor 1 equals 10 ohms again. Resistor 2 equals 20 ohms, as we did the, that's an, see, I messed that one up, but I know what I'm trying to say. So now I'm going to try to find, actually, you know what? We're not going to include 9 volts. What we're going to do is we're going to do the current present in this circuit is 5 amps. That's what we're going to do. There we go. So now we'll have to find the total voltage. So first things first, the equations for voltage are voltage total equals current total times resistance total, as we know. So current total, we have that. Current in a parallel circuit is always the same. That means on this branch, it's 5 amps going through there. On this branch, it's 5 amps going through there. It is always the same on every branch, unless it's a combined circuit, which we will talk about here in a second. So the thing we need to worry about is this resistance total. So we talked about this in class, and this is the most unnecessarily complicated equation in the world. But we're gonna write it out anyway. So resistance total in parallel is equal to 1 over R1 plus 1 over R2, and then in theory I would go plus 1 over R3 plus 1 over R4. Again, I hate it, you hate it, we all hate it, but that's how it has to be. So another way you can write that is resistance total equals, in parentheses, R1 to the negative first power plus R2 to the negative first power, all to the negative first power. So that's another way to write it. Some of you may choose to do it that way. That's totally fine. Just know that these two equations are the exact same thing, just written differently, and whichever one makes more sense to you, I want you to use. Make sure you tell me, though, which one you're using. Don't just put random numbers down and then somehow it comes out to a number. I want to know, did you use the exponents or did you use the fractions? Cool. So we're going to quickly solve this one. So you're just going to plug in these two numbers right here into these. So I'm going to use this equation because I like it a little bit better. So 1 over 10 plus 1 over 20. So if we do this, that's going to be 0.1. This will be 0.2. So I believe, yeah, that should be right. So 1 over 0.3 equals resistance total. I don't have a calculator again, so I'm not going to solve that. That'll be okay. So now we take this and we plug it into our final equation. So voltage total will be equal to our 5 amps, our current total, times 1 over 0.3 ohms. Simple stuff. And reminder, just like we did on that last problem, if for some reason this was 20k ohms or if this was 10 milliohms, you need to make sure you adjust the value so that it's the base. Okay, So last thing we're going to do, I know this is getting kind of long. I'm sorry. I will try to get them shorter from now on. But last thing we're going to do a combination circuit. So what that means is there are resistors there's resistors in parallel and in series all in one lovely circuit. So what we're going to do, excuse me, so we're going to have a circuit over here with our battery source right here. We're going to start with one resistor there, resistor 1, going down, over here resistor 2, and resistor 3. So reminder, when you're drawing out circuits, if you have wires that are connected, you like a point of connection, you need to make a little dot. That just is proper way of drawing a circuit to show that these wires are connected. Otherwise, people may assume that they're just crossing over each other and not actually connected to each other. All right, there we go. So resistor 1 is going to be equal to, let's do this one's going to be 10K. Resistor 2 is going to be 20 ohms, and resistor 3 is going to be equal to 100 ohms. So we are going to try and solve for resistance total, and we're going to try to solve for, let's do current total. So, and current total. So those are the two things we're solving for right now. Our voltage, we're going to go 9 volts, pretty classic. All right, so first things first, I like to simplify this circuit. And how I'm going to do that is I'm going to take this section right here. We did this in class once. I'm going to basically solve resistance total for these two and make it into a single resistor. So, okay, we're good. Got my calculator on here, as you can see. So what I'm going to do, I'm going to solve for these equations right now. So resistance total, that's going to be, so starting with these two down here, our equation again equals, I like to do the 1 over R1 plus 1 over R2. So I'm going to plug in my numbers. Okay, I'm going to try to keep this on in the video. Okay, that's good. 1 over 20 ohms. And because they're both base ohms, they don't have any kilo or milli in front of them, I can just use the numbers as they are. So 1 over 20, 1 over 100. So if I type that in here, 1 divided by 20.05. Oops, I was wrong on the last one. That's good. Plus 1 divided by 100.01. So that's all over 1. So 0.061 divided by 0.06. There we go. So the 0.06, I have all that. So 0.06 over 1 is then equal to our resistance total, which means that, as you can see on the screen right here, 16.6 repeating is our resistance total. So I'm going to put 67 ohms. So I'm going to quickly redraw this. And so I'm going to have our power source, resistor 1 still, and then I'm just going to make this resistor 2. I'm going to pretend that resistor 3 doesn't exist anymore, but in reality, because I solved for the total resistance in this exact area, that means all of the power in the current going through here basically just hops from here straight to here. So I'm going to make a single line that goes down the middle with a single resistor, as I did right here. So resistor 2 is going to be equal to the resistance total we found, 16.67 for that section. There we go. It's a little hard to see, I'm sorry, but bear with me. So resistor 1 still equals 10K ohms. So now we have our 9 volts and our 2 resistances. So resistance in series, much easier. Resistance total in series is equal to R1 plus R2, which in this case is equal to 10K. So as we did with our little chart thing before, I'm going to move my decimal place 3 to the right in order to adjust to make it the base value. And that's plus 16.67. So our resistance is 10,006. Oh, that's 16.67 ohms. So if I wanted to make that easier number, I'm going to make that 10.0167 kilo ohms. Okay, I barely feel the paper. Perfect. So that's a little weird. That's a weird number. I'm totally aware, but that's okay. So now we just want to solve for current total. Excuse me. So current total up here is equal to voltage divided by resistance, which we have our voltage right here. So we're going to plug that in, 9 volts divided by our now new total resistance over the entire circuit. So that's 10.0167K. So 10, move that decimal place back to the right, 016.67. That's going to be a weird number, but that's okay. 16.67. Yep, that's a wild number, but that's totally okay. So that means our current total, oh, you can't see that. Let's move this out of here now. We're done with you. So that means our current total is equal to, as you can see on the calculator, this weird number. So we have 0.0008985. So I'm going to adjust that too to make that a better number. So I'm going to move that my decimal place through to the right. But because, as we remember, moving the decimal place from the base to the right makes it milli. So 1, 2, 3, 72.899 milliamps is our current total. There we go. So that's how you solve all of them. So I included the PowerPoint that I went over in class with you with all of those practices examples on it on Classroom, so you can look at that if you have any questions. You can obviously watch this video, so that'll be hopefully be helpful. And all I want you to do is there are a few practice problems on Classroom, and that's going to be kind of your work and your homework and whatever it is now. So just get those done before tomorrow, before we and so yeah, those will be due by tomorrow, pretty much. Yeah. So make sure you get those done. If you have any questions, please let me know. If you have a question, so let's say you're working on a problem like this, and you're like, I don't know how to simplify it. Well, draw out what you think you would do. So you would draw out the circuit as you have. I would recommend doing it on paper. It makes it easier if you can. If not, there's ways to do it on a computer or on your Chromebooks, but that just it's hard. So include the drawing and then say, I started resistance total, but then I started it and I got to this number, then I couldn't remember how to redraw it as this. So just let me know exactly what you did, and I will do my best to respond to your emails and help you figure out how to complete it. Again, sorry this was so long. I just had a lot to get through, and tomorrow we're going to be talking about something new. So just do those practice problems and let me know if you need help. Awesome.